Machine learning. Is it something that I can do myself, or should I hire a professional data scientist? It's a valid question, and the answer is it depends on the data that you have, on the complexity of your use case, and many other factors. But in general, there's a wide range of problems for which you don't need to be a PhD. All you need are the right tools and proper guidance. In this video, we'll take a stab at a simple use case, and I'll walk you through the specific steps required for building a machine learning solution. And I hope that by the end of this video, you'll get some clarity around what it actually takes, and also perhaps about your own use case and whether or not you can build your own solution. My name is Alexander Korobov, and this is Machine Learning DIY. Consider a simple hypothetical use case. Let's say we're producing diamonds and we need to estimate their preliminary prices based on their basic features like size, carat, clarity, etc. Let's say that we have a historical dataset containing these basic features together with the prices of diamonds. Would we be able to use that data set to infer the pricing logic so that going forward we would be able to price diamonds using their features? Let's run an experiment. We'll use a publicly available data set containing diamond features and prices, and we'll build a simple prototype solution from scratch. Let's go. Start by creating a Google account and sign in. Search for Google Colab. Create a new notebook. Let's rename it to Diamonds. This notebook will be our work environment. It'll allow us to send instructions and view results. Our first instruction will be to install a package named H2O. With Google Colab and H2O, we have a decent pre-configured computational environment that is user-friendly and scalable. You can use it for many other projects. Once the package is installed, we need to load it into the notebook and initialize the engine that will run in the background. Now that we have the environment fully set up, we can proceed with the next step and load the data. Our data is simply a table with 54,000 rows, where different columns correspond to different diamond features, carat, color, clarity, and so on. We also have a column with the historical prices of diamonds that will learn to predict. Different rows correspond to different diamonds. The next step is to split our dataset into two parts. We'll use 80% of the rows for training the model, and we'll put aside 20% of the rows for validation. The rows will be selected randomly. Here's our training dataset. It contains about 43,000 rows. Similarly, this is our validation dataset. It has 20% of the records in the original set. And this is perhaps the central step in machine learning, training the model. For this step, we'll be using a model called random forest. These types of models require minimum tuning and are usually quite robust. With the commands in this step, we're instructing the machine that we need to use a random forest model, and we train the model by specifying what columns will be used as predictors, denoted with X, what column will be used as the target, denoted with Y, and which dataset will be used for training. The next standard step is to make predictions. Let's estimate prices for our validation set that the model hasn't seen yet. The model will only use the features that we specified as predictors, and we'll store the predictions in the validation dataset as a new column. Let's call it preds. Also, let's create a copy of the validation dataset to be used later for visualizations. Let's evaluate our model. How well does it predict? Is it fit for purpose? The most intuitive check here is to simply compare the predictions made by the model to the actual prices. If they're close enough, we have a good model. If they're far apart, we need to improve our data, our model, or perhaps we need to conclude that the use case is not feasible. To make this test realistic, we should only use the validation set that the model hasn't seen before. In the produced graph, the x-axis corresponds to the actual price, the y-axis corresponds to the predicted price, and each point corresponds to an individual prediction. If our model was perfect, we would see here that all dots fall on the diagonal line. Our model is not perfect, but it does the job. And in general, there's a pretty good correlation here between the predicted and actual prices. As you can see, it only took us a few minutes to go through all the steps, and we've built a decent prototype for pricing diamonds. In fact, we spent most of the time on preparing the environment. The beauty of machine learning is that it is not domain specific. That is, you would follow roughly the same steps and approaches and use roughly the same tools to price diamonds, to price cars, or predict click-through rates. In the next videos, we'll be able to delve deeper into various steps and aspects of machine learning. See you there.